My name is Ashish. I'm product manager at Microsoft. And some of this is just my drawings, my attempt at understanding some of these protocols myself. If there is kind of misstep and I kind of speak wrong, please correct me. I'm here to learn as well. And I'm trying something different. This is a new tool that I'm trying where I've created some drawings and then using it as a presentation. So let's see how this works. So what I wanted to do in this slide was kind of walk us through just the evolution of AI-based assistants, now kind of agents, right, over a period of time. So go back to time, probably early 2022, where we were interacting with ChatGPT. And most of us were kind of throwing questions back and forth and getting kind of answers from the world knowledge of the LLM, right? So this is that time where we would prompt and we'll get something back from an LLM. We're still doing a bunch of these interactions, but again, it has become a little bit more sophisticated under the hood. These models called tools as well. So we'll touch some of that. When its very first kind of incarnation, it was pretty much spitting out everything from its world knowledge, right? And that was this kind of chatbot phase, as I've tried to list it. Then things started to become more interesting. RAG came online, which is retrieval augmented generation. And the whole notion was the world knowledge of LLM is great, but it's frozen in time. And again, trained on a bunch of data. How do I get it to talk my language, my enterprise language, ground it on my enterprise reality and stuff like that? And that's when kind of retrieval augmented generation came in, where you could augment the knowledge of these models by your own data, right? You would index them, and then there's this kind of search on top of it, which takes your queries, goes and searches a bunch of data, brings it back, ranks, re-ranks, whatever stuff is happening in terms of RAG optimization. But ultimately, you're hitting the RAG pipeline to augment the LLM knowledge. So that was then. And I've labeled these as assistants. They become a little bit more intelligent. They kind of have this enterprise context and things like that. The third phase is where kind of we are living right now, right? Which is obviously there's RAG augmentation, but there's also tools involved, right? Some of these LLMs can do things for you, maybe set calendars, send emails, draft a reply that you can then post somewhere, check for weather, check for open table, whatnot, right? That is where now these things are becoming more agentic. They can take actions on your behalf. And I've used agent loosely here. So again, agent can involve a lot of things, but two or three key component for me is it should have reasoning capabilities. It can do a little bit of planning, figure out the right tools to call and things like that, right? So it's getting into that agentic space. Sure, there could be memory and other things as well, which kind of classify things as agent. But again, I'm taking a kind of loose definition of agent here. So this is where most of us are living. Most of our interaction with ChatGPT is kind of like this as well. The new world of scalable agents is where kind of now MCP comes into play. One of the issues with this kind of interaction is you're hardwiring these tools, you're hardwiring these kind of RAG implementations into your LLM, and based on its reasoning, it's kind of trying to call them. But as your tools, as you want to add more tools, let's say, right, or want to bring on a new data set, you have to go back and change your kind of LLM logic, your orchestration logic. Not so much LLM logic, but your agent logic. And that can create regression and so on and so forth, right? How do we get to something of a microservice architecture which can kind of scale, right? So that's why I'm calling these as scalable agents. With MCP server, you can kind of bring on board these new servers which have access to tools, and your agent can now discover these tools, query for these tools, get a listing from the MCP server, and then call these tools to get tasks accomplished, right? So again, broad definitions, but again, hopefully kind of that makes sense. One thing that I wanted to underscore is these are not kind of the first impressions or first attempts at doing some of these things. OpenAI has been at this mission for a while. And if you remember, now deprecated OpenAI plugins were an attempt to do this, which was you have some API, some service somewhere, create an OpenAI plugin, which was based on, I think, Open API format. And then you can create these plugins. The idea was, again, from an open AI perspective, to create an ecosystem around ChatGPT, where ChatGPT is your kind of main assistant, and then others will create plugins into this ecosystem, and then you can call those systems, whether you're setting up, recording, whether you're ordering Uber, booking tables via OpenTable, asking for weather, doing Expedia, whatever, right? One of the things was this did not become sticky, and obviously that's why it's deprecated, that people didn't want to come to this ecosystem. They want traffic to come to them, right? So that was, at least from my perspective, one of the big reasons why plugins did not succeed. Another attempt they made was using GPTs, where the idea was you will create all these GPTs which have kind of custom logic, have access to custom actions and knowledge, and then your chat GPT can call into those GPTs and kind of do fun things. They're still around. I'm not sure what's the usage. OpenAI has never kind of publicly kind of declared the usage of these GPTs, but again, people have created some very good stuff. Really, the grandfather or the father of this concept of MCP came along with function calling. That ability for LLM to decide, hey, I have access to these functions based on the call. I can formulate a query and call this API or this function. That is kind of the fundamental principle around MCP. So that kind of stays and has come a long way in that sense. I've also seen people kind of confuse SDKs to build agent and these protocols. I want to kind of create that separation as well. The three kind of at least leading protocols that I have seen in terms, and I'll create what's their scope as well, is MCP, which is Model Context Protocol from Anthropic. It's all about kind of tool and resourcing. Agent to agent recently arrived a couple of weeks back from Google at their Google I/O conference. That is more about agent-to-agent conversation. And then there has been effort from MIT as well, network agents, decentralized agent called Nanda, which is kind of a little bit broader scope. So we'll talk about that as well. So these are kind of protocols of agent-to-tool interaction, agent-to-agent interaction, and then a little bit broader scope as well. On the SDK side, again, these are few, but there are kind of many other where you can go build your agents. So LangChain, AutoGen from Microsoft, CrewAI, OpenAI has its own SDK, and then Semantic Kernel again from Microsoft. Those are some of the agent building SDKs where you can kind of go build these agents. Between the three protocols, if I kind of split them on just scope, MCP is this kind of smaller scope protocol in that sense. It's purely resource oriented or tool oriented, right? So whether you're augmenting your agent with new knowledge or tools, that is the scope of MCP. Of course, Anthropic might be planning to expand. There's a ton of contribution into MCP. MCP is an open source protocol, but it's not truly open source. Anthropic still kind of approves all your PRs, right? So even if you're contributing to that, Anthropic holds the key to the chest. Google's protocol is a little bit broader. It's not limited to just tools. It's primarily an agent-to-agent protocol, peer-to-peer in that sense, that you can call another agent to delegate a task in a synchronous or asynchronous manner. So both are those possibilities. And it takes a bigger kind of scope in that sense. And then Nanda protocol from MIT is even broader, right? It also has its own protocol, which is called the Nanda protocol, based on top of MCP. But then it takes a bigger approach around architecture of how will these agents exist, how will the discovery work, how would economics between agents work. If imagine a situation you're trying to set up a birthday party, you have to do catering, you have to do decoration, you have to order plates and whatnot. And you can ask your agent to go curate that birthday party and can kind of talk to these other agents from these other agencies which offer these services and kind of negotiate, collaborate, and kind of set up stuff for you, right? So that's kind of a canonical scenario. After that, let me actually walk through this diagram that I created for myself to understand this landscape. Imagine a future state, and again, this birthday example was a good state, right? When most of the business logic moves from the application layer to agent layer, And everybody's offering, just like everybody offers today, a website, an app for you to interact with their services, agents also, right? So these are kind of first-party agents from these services, whether you're booking Expedia or booking Uber or whatnot, right? You can interact with these agents and get stuff done. So imagine kind of traveling for work or pleasure and saying, hey, here's my itinerary. Go book me Ubers back and forth from my house to airport, airport to hotel and whatnot. And then your agent goes and kind of negotiates with different kind of taxi vendors, figures out the right rates, arrival times, all of those details without you having to kind of open an app ever again. Right. So that's the kind of future possibility that we are looking at. So here in this kind of diagram, if you look closely, Agent one has its own LLM orchestration, has access to its own local knowledge, tools, and resources. All of this is local, but then it can also have access to MCP server. Now, I published a version of this diagram in past where I had called this access as remote access, so I'm revising that. Based on my kind of latest reading and understanding, think of MCP servers as, if you remember the time where we were side loading application, right? You are actually side loading somebody else's kind of MCP server on your kind of local environment or your agent environment, and the server has access to remote access, could have remote access to tools. So the server is still local. You are actually side loading it, and then it has access to tools which could be remote or local as well. Right. So that's your kind of agent that is working for you. Let's say, imagine. And then it could work with another agent using the A2A protocol, which is remote access. And what Google has done is defined a bunch of things. Again, it's still a client-server protocol. Each agent is advertising its capabilities, its offering using an agent card, so it exposes what it can do for you. Using the agent card, again, could be synchronous, asynchronous, streaming back and forth results. But the idea is collaborative versus delegation. In case of the MCP, the idea is delegation. You're delegating and you're asking for some information. In case of A2A, a lot of it is collaborative, working between the two agents. Now, this agent could also be kind of working in a similar setting as the previous one, but it could also be working with other agents as well. Now, MCP lets you work with tools, knowledge, and other agents, but all as tools, right? So this third agent might be collaborating with agent B via MCP protocol, but using the agent C as a tool, right? Not as a collaborative agent. So I'm just trying to kind of create distinction that way. Let's see what else we have here. So kind of a little bit of deep dive into the three protocols. From a scope perspective, we talked about MCP is tool-centric and data-centric, so knowledge and actions. A2A is agent-centric, so agent-to-agent collaboration in a peer-to-peer format, delegating and getting updates. And then Nanda is taking it a step further where it is talking about decentralized AI, discovery of agents, registry of agents, right? Almost kind of creating that ecosystem around agents. My guesstimate is Google's intent is also to go in that direction. That's what A2A does. It has a lot of discovery-based things in their documentation. They've just not spelled it out as an agent registry of sorts. The communication protocol, both MCP and A2A are in the sense compliant. They are JSON RPC, and then A2A uses SSE server-side events to communicate bidirectionally. Discovery metadata, there is no central registry in case of MCP, so you're kind of mostly likely downloading servers that you know of, somebody has told you. Google is starting to create a discovery mechanism with agent registry or agent cards, but really Nanda is kind of leaps ahead in that sense that they have created this notion of global registry. Anybody can create a registry to create these decentralized kind of yellow pages of agents in that sense. Security governance, there is a ton of issues with MCP as from a security perspective. For the same reason, it doesn't has auth well defined. And the idea is you're kind of side loading these servers on your in your agent environment. So again, from trusted sources, that might be fine, but if you don't trust those sources, that can be an issue. People have actually created sniffers on top of this, which can sniff your MCP code and everything that you are downloading to figure out if there's malicious code in it or not. So there's a ton of concerns around that. A2A and Nanda both have authorization auth built as part of the protocol, so that's great. Thumbs up on that for them. The modularity of data for MCP is purely JSON and textual content. So you're receiving content as JSON payload, textual content, but A2A is multimodal in that sense, and same for Nanda as well. The state management is stateless call. So again, every call is kind of net new call for MCP. But in case of A2A, these could be long-running tasks, and you're exchanging states and updates and events going back and forth as well. And then Nanda adds workflow orchestration, economic settlements in multi-agent kind of tasks, and so on and so forth. Those are kind of the big, some of the backing. MCP has a huge adoption, like it's kind of almost become RAG-like terminology. Everybody's talking about MCP. So rapid adoption from a lot of vendors. Google is a new entrant. They announced 50 partners in their announcement again, but we don't know how long, how deep that partnership is. And then on Nanda side, it's still just growing. It's academic at this point of time. But again, Ramesh is creating a lot of kind of interest around that space. Limitations, we talked about authentication and safety and security limitation, no kind of discovery. It's primarily side loading of MCP. On the A2A side, still evolving, not very clear. Cost of streaming could be high. Complexity of state sync could be high because, again, you're sharing that state machinery between agents sometimes. And then with Nanda, it's again early stage, unclear. Again, adoption itself is unclear in that sense. And how will the governance look like? That's kind of unclear. With that, that's it from me. Paul, happy to kind of turn it over to Kevin. Happy to answer questions as well.
Yeah, let's do a few questions here before we go to Kevin. Questions or clarification questions for Ashish? Yeah, go ahead, Mike.
Yeah, so thanks, Ashish. Yeah, I was on that same call, what was it, last week with Nanda? And I found it very curious. It's early stage, it looks great, but one of the things that they emphasized is the decentralized nature of what they're putting together. In a different life from 6 months ago, we would have called that blockchain.
It still is blockchain.
No, we call it DLT. That's cooler now.
Okay.
But anyway, so, I look at this and I really think Nanda has hit it right because they have the foresight to think about commerce. How can I do business with Paul and Ashish and Jeff? And that's surprisingly something that a decentralized system can do as well as a old-fashioned database. So good stuff, though. Thank you.
Yeah, absolutely. I agree.
Go ahead, Jeff, and then we'll go to Kevin.
All right. Hey, Ashish, thank you. This is great. I've wanted to spend more time into these protocols, but haven't had a chance. So this was very educational. I appreciate it. I have spent a little bit of time thinking about this, and I'm just curious your thoughts on the global registry requirement for Nanda. I kind of envision, you need a central standard to ultimately hold all of this stuff for agents working together and discovery and so forth. But any time you're working with a decentralized system that rides on a centralized backbone that runs everything, there are risks and challenges for that. So I'm just curious in looking at these different things, if you think that's a weakness or if that's a good thing, or we don't know yet.
I mean, I feel it's a strength, not a weakness, because I hope agent world is not like app world where there are two curators of application registry or discovery in that sense. So I would imagine that this is more decentralized than the app world was. As long as the protocols, as long as we can talk the language, so that's why protocols are interesting, are there, then agents could work across boundaries, registry boundaries, probably, hopefully. Let's see.
Ashish, before we go to Kevin, in your mind, what's the benefit to application development using these protocols? Is it cheaper, faster, more nuanced?
Yeah. Protocol. So imagine if you were developing an agent offering GAI insights, data, and just insights that you guys curate, and I'm the consumer. If we cannot talk the same language, somehow interact, then all those services, all of that good curation that you have done, I cannot harness it. I cannot leverage it, right? So we might be developing our agents independently using different SDKs altogether. But if we can talk the same language, that's what the protocol kind of bridges. It creates the bridge between the two. Then I can leverage your service and say, hey, Paul, I'm interested in this data that you have been curating, right? What's the price of it? We can negotiate all of that. And then since we talk the same language, we can interact. We're in business then.
Great,
But if they don't, then we can't talk. There isn't a common language.
Great, thanks. We'll go Douglas and then Kevin. Go ahead, Douglas.
I just
Douglas,
timeline. Oh, I'm sorry.
Douglas, you
Can
faded
you
out.
hear me?
Yes.
Okay, I'm curious what you see as the implementation timeline around these technologies. Is this, imminent? Is this a year out? Just curious.
I feel within a year we'll see agents working together, right? Each other. Initially, it will be more curated, so there isn't like go discover all the taxi services which are offering transportation from kind of X to Y, but might be more curated. Hey, here are the 2 taxi services that you're aware. Go pick and figure out things. It'll be more curated that way. But discovery is super important for all of this to work, right? So if I say, hey, my agent, go figure out the cheapest, most reliable taxi service to take me from home to airport, and it can go negotiate with the multiple players, figure out the costing, right? Anything that you would do in apps today, right? A lot of times I'm standing there at the airport and having Lyft open as well as Uber open, see which one will arrive faster, which one is cheaper and more convenient, all of that, right? We can offload a lot of that cognitive overload to the agent. It can work on your behalf as long as it can kind of interact with those agents.
Great.
The sooner the better.
Yeah, go ahead, Kevin. Michael, let's hold on yours. I want to get Kevin in here, and then we'll open the Q&A. Thanks, Michael.
Okay. Great stuff, Ashish. Very educational. Thank you. It helped me deepen my technical knowledge on this as well. So I'm Kevin Petrie. I'm VP of Research with Barc, which is a global research and consulting firm. I also run the data management practice at Barc, which encompasses research, consulting, and events. And so I'm very focused on the data layer, how it supports AI, as well as the AI layer. And what I could do is quickly provide a little perspective. One of the things that we do at Barc is we have survey data about adoption trends. And if we look back, the notion of agentic AI really was not mainstream or even being talked about in a meaningful way 13 months ago. Now our surveys are showing that 1/3 of companies say they are in production with agents, which is an astonishing pace of adoption. A lot of them are in all likelihood using agents that are actually features of commercial tools. But I think it's fair to say that there's very rapid pace of adoption. However, it's kind of narrow in terms of the benefits organizations are getting so far with AI. One of the things that GII Insights flagged as essential reading was the Stanford Human-Centered AI Institute came out a couple weeks ago with their 2025 State of AI Adoption. They showed that overall companies are getting about 5% or less incremental improvement on cost or revenue from AI. And so I think it's going to take time. I agree with the future of having agents talk to each other. I agree with Ashish that we could have that happening sooner rather than later, but it'll probably be more standardized basic use cases for the near term, because a lot of companies that we talk to, especially from a data perspective, the models are incredibly powerful. These new agent development frameworks are pretty powerful to help start to put stuff together, but the data is not ready. And so that's where organizations are taking a much harder look at their data layer from a governance perspective. One of the things that I wanted to point out was that the agent-agent protocol and multi-context or model context protocol, I think, are really good lubricants to help three different life cycles work with each other. So you have data engineers that build pipelines. They design them, they build them, they orchestrate them. These pipelines feed vector databases, they feed relational databases, and so forth, that will help train and support inference for these models, GenAI language models in particular. You've got another life cycle, which is designing, implementing, and orchestrating models. And so that's where data scientists are figuring out how to use GenAI language models alongside predictive ML, alongside classification algorithms and all kinds of things. And they need to figure out, they need to train those, put them into production, and then orchestrate them, promote some, demote some, and so forth. So that's another life cycle. And then the third one, of course, is the application life cycle, where you've got application developers that are building these things. And I think those three groups of people are still figuring out how to talk to each other. So that'll take some time. Data engineers are getting more savvy about data science. Data scientists are getting more savvy about data engineering, and so forth. But it will take some time. One thing that's happening pretty quickly is that vendors, the hyperscalers like Google and so forth, and Microsoft, are getting very involved in facilitating these agent development frameworks. And that's great. I think that Google's agent-to-agent protocol is a good step forward. Notably, they don't have, to my knowledge, Microsoft or AWS supporting them yet, which might be a limiting factor. Model context protocol does have, I believe, support from all three. So that could be one gating factor in terms of which protocol gets more widely adopted. But on the data management side, there are a lot of companies. Domo is one, and there are others as well, Boomi, that are helping create these development frameworks for data managers, for analysts and so forth, so that they could start to spin up their own basic agent frameworks using MCP, using other things. And if we look at what MCP enables in particular, it's sort of instant access to data that's residing within software as a service within all these SaaS applications and so forth. That's great, because if you're interacting with a GenAI language model, you want, for example, instant access. If you're a customer service representative using a service agent, you want instant access within Slack to any service tickets that involve that customer. You want instant access to the relational database that shows their purchase history and so forth. And so that instant access is something that MCP can help with quite a bit. It's going to complement retrieval augmented generation, which is going to help feed things on more of a periodic basis. So you could have retrieval augmented generation that's going to find things on more of a periodic basis. It could pull up the latest information, but it might not be that instant access to the applications that MCP can provide. So if you're looking to train a model, if you're looking to feed it the right context, RAG helps. If you're looking for instant access to that very latest information, that's where MCP could be very interesting. Another point I quickly make is that we've done survey work on what types of use cases folks are looking at for agents. We asked specifically about data management agents, and we saw pretty high demand for companies, data teams that want to use agents in order to manage data more effectively. So we've been talking about data to support AI, but AI obviously supports data management as well. And I'll just provide those real quick. We found that, where is this here? About 50% of folks said they'd like to use agents to manage data quality. 38% said they'd like to use to integrate data. Others want another third, say, data documentation and data classification. So there are a lot of ways in which agents can assist with data management as well. So there are a lot of ways in which these three life cycles, data, applications, and models, I think, are coming closer together. And those teams are starting to use the latest technologies to support each other. And I think MCP, agent-to-agent protocol, and Nanda are all good lubricants for that.
That's great. Thank you, Kevin. Questions for Kevin? Kevin, where do you see this going? Is this little just improvement of the API pipes, or are we going to have agent-based applications 2 years from now that going to
I
last?
think we will. I think we will. And I think we'll even have agents talking to one another. On a recent call, I thought John evoked a pretty cool future in which you can have markets of agents. So you could have an agent, you give it a certain maximum price, bottom price, and say, go find me opportunities on 3 open marketplaces, and it'll talk to other robots to come back and find that kind of thing. That thing will be important, but I think it will have a high level of user interaction because organizations will still want to make sure that the subject matter experts are approving and inspecting the outputs and making sure that they're involved in the action before it's actually taken. So the level of autonomy might not be as high as we might think. And I think the sophistication of the use case might not be as high as we think, just based on the readiness of the data teams that we talk to. But yeah, there's a lot going on. And I think there will be some early innovation.
Go ahead, Lucinda and Mike.
Yeah, this question actually for both Kevin and for Ashish. So what have you seen are the what the early use cases for agents? I mean, I know we've seen a lot of kind of hypey things on OpenAI, but like where are use agents actually being used and being scaled?
Well, let me jump in after you guys. I mean, there's one killer one I use every single day, Lucinda. But
Okay.
Yeah. The most scaled out agent I would say is deep research right now for me.
Yes.
yes.
One of the things that I realized with O3 model is its ability to write code. And the reason the O3 model's ability to write code is different from everything else was in past, you were telling the model when to write code. In fact, if you look at any of the jailbreaks, meta prompts of OpenAI, it clearly states you can write code, but don't write code until you're told to write code, right? And with the O3 model, it saw, I mean, I threw it a picture, and it's my standard picture for visual interpretation. Here is an image of a parking lot. There are 18 cars in it. Every single model gets it wrong. And like find out, count the picture, cars in the picture. And it performed kind of different sorts of iteration for over 5 to 10 minutes, where writing different snippets of code, taking different smaller kind of blocks of images and counting picture. It still got it wrong, but this unique ability of now being able to write code to validate something or get a task done is unique, and I feel that is going to scale massively.
Yeah, and I guess in a way the like Cursor and some of those other environments are kind of embedding it into the developer environment. So
yeah, I think software development is a big primary use case. Customer service is another popular use case.
For agents?
For agents, yeah, in that case. And the term agent gets confusing because you also have human customer service agents. So, but you could have the agent in a lot of cases supporting customer service representatives in the background, helping them, coaching them, and so forth.
So something more than a RAG, basically?
Yes. Yeah. So it can help you with sort of instant access. It can help you with recommending ways to handle tricky clients and things like that.
Let's go to Michael and then Tim. Go ahead, Michael.
Yeah, thanks. So Lucinda, you get my Bitcoin for the day. So the other interaction that I'm seeing is also human to machine, not just agent to agent talking, but I want maybe an agent. I might have 2 or 3 on my desk. Hey, marketing, what's going on with the Novak campaign? Financial, what's the EBITDA for last month? And have them literally talk in natural language with me as part of the conversation. So I know what they're talking about and I can navigate, because I got that meeting in 5 minutes with my boss, Paul, and he's a real buddy. So again, this is now.
Do you have this, or do you?
Yes.
You have this right now.
This is something I've been working on. The short answer is yeah. We can talk later, but yeah, follow up with me. Number 2, who was it? Kevin or Ashish, one of the others. About the marketplace.
Yeah.
That is going to be interesting. What I am currently this last 2 weeks focused on, though, is again the fight over define what open source means to me. Because currently everyone says this is an open source thing they've built, but it's still managed, controlled by somebody who has money is how they get measured. I'm also doing some work with a nonprofit called the Linux Foundation. You may have heard of it. And so we've been doing evaluations of models even before this. But it's going to be the next 6 to 12 months of, hey, I want to use this type of agent based on the number of rating it got from people I don't know, based on what my internal policy is, based on my, whatever I want. So that's just going to be a huge market to figure out which agent is best for me at this point in time.
Okay. All right. Thanks.
Go to Tim.
Yeah, so I guess we were talking about protocols, and agent protocols. So it drives me a little bit nuts how little context there is. We have this very large, somewhat agent-based environment called the internet. It's very decentralized. It's scaled far greater than any other system we've ever seen, and it's never crashed. And yet we fail to study it. So I put a link in the chat of an article that will probably seem quite technical, but was actually written by a psychologist. And he ran the ARPA office. His name was JCR Licklider. And it was about communications with aliens, the way he kind of talked about it. And that was where the whole ARPA community talked about it, because that is the fundamental problem. What's the likelihood that some agent I'm really interested in communicating with actually is communicable, actually knows how do I find out what it can do, and how can it find out what I can do? And that problem is a hard problem, but one that the internet kind of found a reasonable solution to, and it's one of the reasons it scaled so well. So Nanda and all these other things are the classic solutions, which is I'm just going to get a bigger and bigger yellow pages. And there is potentially ways to make that work, but even DNS, for those who understand it, doesn't really work like that. And it's because it's really hard to keep those yellow pages up to date, and everybody has to agree how the yellow pages are going to work. If you ever try to get 2 software developers to agree on something, imagine trying to get 1 million developers to agree on how agents are going to work. So we have little walled gardens like the Apple App Store and the Google Play, but they're walled gardens that are controlled by a single king. And so if we really want a decentralized thing, there's more to be understood in how to make it work. And if you want me to put it in one sentence, there's an old saying in computer science that every hard problem is solved by another level of indirection.
That's great. Thank you, Tim. I'm curious, Ashish, go back to your earlier comment talking about how business logic's moving to the agent layer. So in my words, with Lucinda, I mean, to me, OpenAI Deep Research is such a great example of a multi-agent in production today.
Yeah.
Scale, hands down. I say my intention is to go build a research report on topic X, and I'm outsourcing the intelligence, a whole bunch of business logic, where to sort refine my intentionality, which articles to choose, which article, how to format it, which ones include, not include, what to put in the bibliography here. So that's a whole bunch of, in my simplistic brain, business logic. It's now outside my initial traditional foundation of how I thought about this application here. And I think, Ashish, when you said that, really struck me. I mean, is that where you see this is going, where we're moving beyond just, sophisticated pipe discovery and, being able to seamlessly capture data from different things who don't know each other, to actually adding more and more business logic to that? Or did I misunderstand you?
I feel the separation of business and logic and data has been there for a while, right? I mean, we've all these architectures which separates out data layer and your application business logic layer. The point that I was trying to make is that is going to move from an application layer, which has a GUI and underlying business logic, to this agent layer, which you can interact with voice and text and all these other kind of modalities. And might not necessarily have a UI to work with anymore, right? So your agent, your personal companion, becomes your UI to the world, right? So when you're interacting with Uber's agent, you don't need to access Uber's UI anymore. Your agent can collaborate and ask for, hey, my trip is from point A to point B. and I'm willing to travel again during this time frame with this budget, and it can go figure out with whoever are the other taxi providers, which service should it pick to kind of perform that trip. But again, so the business logic is at the agentic level, and it can do a reasoning on its own and kind of figure out how to work with other agents. I don't know if that made sense.
Yeah, I mean, I find, I'm probably too deep research thing here, but I find fascinating looking at the thinking part of it, walking through it, and it goes to, so now I'm reading this PDF from the state of Massachusetts. Oh, I don't like this. Now I'm going over there here. So, it's implicitly must having, different sub-agents, one's deciding, the other one's evaluating here. So it's almost like we're going to have this whole plethora of these little subtasks. And I'm just going to say, I want a good weather report here. You decide which of the 3 APIs to pull. You constantly monitor that. If one fails, you quickly go get the backup on it. I want to outsource all that design logic thinking into these agents that are almost like a Home Depot commodity subtask.
Yeah. You remember, Paul, there was, so some of that thinking is important because, again, that creates transparency, auditability, and stuff like that, right? But also remember there's this Anthropic paper which came out recently that a lot of the chain of thought that we see in these models, especially when the reasoner models, right? Not the deep research, but the reasoners, that chain of thought is actually meant to be consumed by humans. So the model almost gets the answer and then gives out the reasoning for it so that it kind of makes sense to the human reader.
So it's a feel-good one. Let's go ahead, David, and then we'll go John.
Yeah, and Paul, you may have been touching on this sort of too, but Tim, what you were saying about the, another level of indirection, or sort of how are the agents going to talk? And maybe this has been covered, but I didn't really hear it directly. Since LLMs are so good at language translation, that's one of the things they're really great at. Why not have an LLM or a set of LLMs be the things that navigate between the agent communications, because they're better at figuring out how to do language translation than anything we could manually do. And I'm just sort of wondering what people think about that as an agent moderation structure.
I think it's a great thought. Yeah, I think it's a great thought, and I think it should be used more right away, even today, in various things. I think the issue that this subject is raised, and it's a good one, I think it's actually going to be 99.9% of the communication will be between agents, almost all of it. And at very large scales, there is a need for engineering, a little bit of engineering. So these things, because you don't want to have to ask an LLM in every interaction with hundreds of billions of agents, hundreds of millions of times a second, do a little translation for me. But you could ask these things to help you design a meta protocol as to discoverability and things like that, a decentralized protocol. And then you could ask it to integrate legacy systems with that, or integrate your own system with that without having to do much. And I think that would be very valuable. But I do think, and I could be wrong, I do think at runtime, if you think of billions, hundreds of billions, trillions of these little agents all running around in the background doing things, it is going to take some coordination at an engineering kind of level. So I think it needs to be a little more precise.
That makes a lot of sense to me, but I think also what you're saying, I mean, suppose the LLM dynamically spawns runtime efficient code. So it gets this thing, it figures out the translation, and then it instantly writes it and lets it run fast. I get your point.
It's possible it could do it. Look, that's, there were people who did this back in the day and wrote threaded engines that actually generated machine code dynamically and made interpreters thousands of times faster. They were very great at doing that. So it's possible. I just, I'm a little too, I can't see it. We need the next, smarter generation to come up and probably come up with that stuff.
But David, that's the point that I was making earlier. Like if you see O3 and O4, they are doing code generation, not when you're you're not asking for code generation, you're asking for a task to be done. And think of it as LLM, you have the permission to write code when you think it's appropriate, right? That's what it is doing. So you're asking for a task. If the LLM round trip can do it, it's fine. Otherwise, it's writing code to get that task done.
That's cool. Yeah.
Great. We're at time. Any last minute contributions? I know John, a few other. Igor, you had your hands up. Any quick ones?
Let's go for a second round, Paul.
Oh, well, really, thank you, Ashish and Kevin. Fabulous.
Thank you.
Discussion as usual. Let's keep the learning going, and Learning Lab's going to keep driving. So next week, please join us again. Thanks, everyone. Have a great week.
Take care, folks.
Thank you,
Thanks.
everyone.